Okay, day 11. Here we go. Okay, this is interesting. Okay, this is interesting. Interesting. Okay, so for starters, let's try and parse this. Monkeys. This is going to be a little bit annoying. Sorry. Showing the one number there, this is the monkey number, and then the starting items. It's going to be nums at the next line. And then the operation. This one's going to be a little trickier. For now, let's just do this. And then the test, divisible by 2. Okay. Are these all divisible? Yes. And I think it's always if true. And then if false. Right. Monkey number. What do they call that? Starting items, operation, test, if true, if false. Let's see if this looks right. These don't seem right, so what's going on there? Oh, silly bug. Good thing I checked that. Also bug. 4, 3. Yep. Okay, looks good. The operation we'll have to deal with in a sec, but I have an idea. Okay. Specs an item with the word level 79. It's multiplied. Word level divided by 3. They inspect all the items. Before it tests. Okay. Let's do this. We'll just make it like starting items. What is it interested in doing? How many rounds? 20 rounds. Okay, that looks good. Within a round, what will happen is for items monkey in create new m items. Let's also just enumerate this. Oops. Okay, And what each monkey's going to do is, I think they inspect every item. And I have a cheese strap for this. So what we're going to do is for items, old is item, and then I think we're going to say new eval. It's a little bit scary, but it should be fine. Monkey, let's see, 0, 1, 2 is the operation. We're going to cut off the first 5 characters. See if this works. The first one was times 5. This looks right. And then the next one is plus 7. This also looks right. Okay, so it looks like this works. So we get the new worry level, and then we do the test, or sorry, and then divide by 3, round down, and then they do the test. So if new mod, let's see, monkey of 3 is the test. If it's divisible, then we do the if true. So then we do new m items of 4. We're going to add the new item. Otherwise, it goes to 5. That's where the new item goes. Okay, so then we get the new items. Goes on the end of the recipient monkey's list. Oh, I see. So it changes. It's interesting. Okay. So not quite how I thought it works. We leave m items like this. And then we'll just do and it goes to m items. So they don't happen simultaneously, is what I realized. So then we just give him the new item. Let's see, he can't, yeah, so monkey can't receive new items while he's in the middle of throwing all this stuff. So I think we do this. And then count the number of times each monkey inspects items. Okay. What we'll do. Two most active monkeys. Monkey business, multiplying these together. Okay. Okay, didn't work. What went wrong? I think monk is going to be Where are we at? We're in the eval. What is... Oh, we didn't pop it. Oops. So when we're done here, this needs to be empty. A monkey needs to finish. Or sorry, it doesn't be empty because he could... Can he throw it to himself? I assume not. So I think this is valid. I'll leave a question mark on just in case. Okay. Let's try this. Rank 15. Okay, just changes. Hopefully this is fast enough. This eval is definitely super slow. But I think this might be fast enough. So what we're going to do... Oh, it's lagging. Something froze. Uh-oh. Out of memory? That's not good. That is very not good. Oh, I guess I am making a new list there. I guess I'll kill this. And then we'll try again. Maybe we just do like 1,000, see how long that takes. How far do we get? Oh wow, this is really slow. Okay, I think we need to parse this better. And then maybe even then, 10,000 rounds is not many though, is the thing. This should be feasible. Let's start by doing this. It gets slower. Why is it getting slower? The number of items shouldn't be getting larger. Oh, I bet the items are getting really large. Like, the number of items isn't getting larger, but the items themselves are. No? Whoa. I mean, I guess something is that we only care about the divisibility by everything. So I think what we can do, for starters, if this is the problem, what was it, the one that crashed? Okay, so this one item is really huge. What we're going to do is we only care about the divisibilities, so we're going to create like a big N. And then every time we check it, we do a divisibility. All these operations are, I think, adding, dividing, like squaring. These are all fine modulo n. So n is here going to multiply by the test. And then whenever we do an operation, we're going to do mod big N. Okay, and now it's going normal speed. Let's get rid of this. Sorry, we care about 10,000 now, right? This shouldn't take super long. Okay, cool. Oh, that's not right. It's a little unfortunate. I did do 10,000 rounds. Maybe this trick doesn't work. I feel like it should, oh, divide by 3 and round down. I think that causes problems. Yes, it does. Shoot. Oh. So what we really care about is, oh, that's tricky. I guess if it's, when can we modulo it? I think it's divisible by 3. I don't know if this is true or not. For now, though, let's do this. Just so we at least have this. Let's knock this back down to, I think, was it 100 or 20? I think it was 20, actually. So does it give the right answer for 20? It actually does, which makes me wonder. I am going to try the sample input, I think. Okay, on my sample input, the first one, it got the right answer. And the second part, I bet it won't. Yeah, it's quite different, actually. And the reason for that, yeah, these numbers just don't match. Okay, let's try this. That still doesn't look right. The reason it doesn't affect part 1 is because the numbers are too small. What do we care about? I think, can we just track like the number and the number mod 3? Is that sufficient? Seems ugly. I guess I'll go ahead and do it though. Okay. Yeah. So what we'll do is now instead it'll be x 0. Okay. And then basically, wait. I'm trying to think about the divide by 3 thing. I mean, I could also just, no, some of these operations are not easy to express like symbolically. So whenever we do a modulo, right, what do we care about? I think we just want to keep x mod 3 as well. Item and item res. And then what we'll do, so when we do this eval, but n should be divisible by 3, right? Oh, it's not. Oh wait, maybe this is simple. Maybe it's as simple as like, I'm not actually sure that works. I don't think it will, but let me just try it. Whoops, my bad. Something changed? Oh, it's because I didn't do the modulus. Shoot. No, it's still wrong for sample. Still using sample, right? Yeah. I really think I do want to keep track of like the residues or something. So when I divide by 3, the issue is just I don't know if I've reduced like modulo something, then I don't actually know of the rounding behavior, how that will work, is the concern, I think. So I think what we'll do is whenever we like modulo, we always want to know the number. Yeah, I think we do just care about like the number mod 3. Is that right? I'm like really unsure about this. If we do this, and this step is the question. So basically, so that tells us what happens to like the number itself. And x will always be the number, x will always be like the number modulo all the divisibility constraints. And then the second term will basically keep track of do this evaluation. Say that we double it and it goes like over. Like let's work through an example. Say that we have like 20, or sorry, we have 10. Our modulus is like 17 or something, and our operation is like doubling, so we get 20, and then it becomes 3. And then we need to divide by 3 and round down. In the world where it was 20, we divide by 3 and round down. Oh, wait. No. Yes? No. Just dividing is like the whole problem here, right? Yeah. So if it's divisible by 3, ew. This is like actually a very big problem, I think. How big do the numbers get? They get way too big. After like 100 rounds, it's too big. How can you do like division for is there like an easy way to do this? Oh. Wait, what? That doesn't seem right. Hmm. Yeah, because like dividing by 3 is just very different here. If not for the rounding down, we could multiply by the modular inverse. But we can't do that here. I'm just going to check the leaderboard. Oh, is it? Oh, it's already capped. Okay. Wow. So there must be something way simpler than I thought. I feel like there must be. How fast was the 718 to 816? That's interesting. Maybe there's like a pattern with the items and you don't need to... It seems unlikely though. Was I overthinking this? Oh. Wow. Okay. That, I just didn't read this line. No longer causes your word level to be divided by 3. Okay, well if you do that, then it's clearly just, you do this. Man. Wow. Okay, that's pretty sad. It's okay. I got 15 for part 1. I'm like decently happy with that. Yeah, and this is the right answer, right? Yeah, it is. So let's get rid of sample input. Oh man, that's what I get for reading the question too quickly. All right, I still got rank 212. That's surprising. I guess the modular trick is not obvious. I came up with it quickly because I'm used to this kind of thing, but it'll probably take a lot of time for people who aren't used to it to come up with it. Oh, but man, that's pretty sad because if I had realized that, I'm pretty sure I would have gotten like high leaderboard position here. But yeah, rank 15. All right. What happened to my global position? I think I fell a little bit. Yeah, that seems right. Oh man. Whew. All right. Cool. So I guess I can briefly talk about the question. I think this is like the first question of the year that has something fairly non-trivial in it. I think like the first part is like fairly straightforward. You just do it, right? You have these monkeys. You have like this thing you need to do where you apply the operation to each item, and then you do this test. And if you do this operation, then you divide by 3, then you do the test, and then based on the results of the test, you throw the new item to one of these other monkeys, and you just go through each monkey, each item, and then you do this like 20 times. Part 2 changes it up, and it says you no longer need to worry about dividing by 3. Yeah, I actually didn't read any of this. I just discovered it empirically. But now you do 10,000 rounds. But the problem is that these numbers, things like multiply by 2, multiply by itself, like square it, there's another multiply by 5 up here. Like, the numbers just get bigger over time. And they get a lot bigger. Like, infinitely bigger, basically. To the point where you can't store it in an integer anymore. Like here, if I had just tried to print... Let's do this. At the end of each round, let's just print like the maximum item. That any monkey is holding. And we'll get rid of this line. And, oh, okay. Yeah, and you can see like this is how big the numbers get. This is like one number. So clearly you can't just do it. And this is, by the way, on round 74. So these grow like exponentially fast. So clearly you can't do this. But the trick is that you realize that like you don't actually care about the numbers themselves. You only care about being able to do the operations and doing the test. And the operations themselves are like add, multiply, like square is also multiply. So these are like basic operations. And the tests are all divisibility tests. So you could actually just keep the number modulo some other number, assuming that number preserves all these properties. I guess I haven't explained why modulo is the right choice there. But as long as these other properties are preserved, like you can still add, multiply, and check divisibility, you're fine, right? And if you've taken a number theory course, remember some number theory. I do a lot of cryptography, so this comes up a lot. It might jump out at you that if you only care about divisibility, you can just care about residues modulo number. So if I only care about whether it's divisible by 13, I can just keep track of, instead of keeping track of x, keep track of x mod 13. And the idea is that, like, if I have x mod 13, suppose that this is like 5, I can add 7 to this number and get 12. And like, I don't care what x actually is. X might well be like, 142? Like after adding, let's see, x plus equals 7. So I know that x mod 13 is 12, and like I still know that it's not divisible by 13. So I can keep track of everything just fine using only x mod 13. So one thing you could do is you could say, oh, well, like, we care about x mod 13 here, x mod 5 here, x mod 19 here, and so on and so forth, and keep track of all of these in like one big vector. You could do that, but it also just so happens that like you can also, if you want to keep track of divisibility by 5 and divisibility by 13, you can instead keep track of x mod, what is it going to be? It's going to be 65. And then at this point, like, if this number is ever divisible by 5, right, like this is 15, you know it's divisible by 5 and not divisible by 13. If it's like 0, you know it's divisible by both, and so on and so forth. So you can just keep track of the numbers modulo the product of all of these divisibility things. And that ends up being, what? Like, this is not a very large number. Like, it's nowhere close to the integer limit. Even if it was, like, Python has arbitrary sized ints, so it's fine as long as they don't keep growing. And this basically stops every number from growing larger than n, which is exactly what we want to fix this issue. The thing that was throwing me for a loop the whole time was I thought we still needed to do the division by 3 and round down, and that is not something you can really do, I'm pretty sure, if you only keep track of the number modulo n. You can divide by multiplying by the modular inverse, but that's like, that will only work, well, yeah, so like, there are restraints on how that works. And for one thing that you can't do with that is you can't floor it. So you can't divide by 3 and round down. You can only divide by 3 exactly. Which means that if it's not divisible by 3, you get like, you would normally get a floating point, but that doesn't exist modulo other numbers. So you kind of just get something that diverges and doesn't match anymore. I mean, either way, like it asks us to round down. We just can't do that really, modulo a number. So yeah, but once you get rid of that, then this works just fine. So if we do this and print the max element, you'll see it never goes over the modulus. And this is after like 500 rounds. So this is completely fine. But yeah, that's Advent of Code, day 11. If I had seen that a little bit earlier, this part here that said this, I probably would have solved that much faster. But, you know, I'm still pretty happy with like a 15 on the first part. That is some pretty good leaderboard points, and I am desperately in need of those right now after the last few days of not getting very good performance on leaderboard. Cool. So that's it for today.